Hey guys, come back to another video. So today we will be talking about how far away the sun really is. During a full moon, the moon is completely illuminated and the sun, the earth, and the moon are lined up. During a new moon, the moon is completely in the opposite direction from the sun. But what happens in between? What happens when exactly half of the moon is illuminated and the other half is in darkness? Let's draw it. First, we draw the moon exactly half illuminated. Because the moon appears exactly half illuminated from the earth, we know that the earth must be somewhere along the axis of the moon's shadow. Let's place the earth somewhere on that line. Now, the moon is illuminated by the sun. So, the sun must be somewhere exactly in front of the illuminated half of the moon. That means the sun is perpendicular to the axis of the moon's shadow. Do you see where I'm going? That's right! The earth, the moon, and the sun form a right triangle, the astronomer's best friend. Now, let's place the sun somewhere along this line. For example, here I've placed it twice as far from the earth as the moon is. Because this is a right triangle, and the angles of a triangle always add up to 180 degrees, the angle at the earth and the angle at the sun are closely connected. If one gets bigger, the other gets smaller, and their values depend only on how far away the sun is. Let's look at some examples. If the sun is twice as far away as the moon, the angle at the earth is 60 degrees, just like in our drawing. If the sun is 100 times farther away than the moon, then the angle is about 89.5 degrees. Okay, drawings are great, but what happens in real life? If you wait until the moon is exactly half illuminated and measure the angle between the moon and the sun, what do you think we'll find? 60 degrees, 70 degrees, 80 degrees, or even maybe 67 degrees? Aristarchus asked himself exactly the same question more than 2,000 years ago. At first, he didn't calculate the exact angle, but he noticed something very important. The angle seemed to be very close to 90 degrees. That meant the sun had to be very, very, very far away. Since the sun and the moon appear almost the same size in the sky, that meant the sun had to be enormous. Look at these images. With the same distance between the earth and the sun, as the sun gets bigger, the shadow gets smaller. If the sun is very, very big, it will have almost the same apparent diameter whether we look at it from the earth, from the moon, or from the tip of the earth's shadow's cone. This was Aristarchus' third clue. Now, he had everything he needed to calculate the size of the moon. We'll see how he did it in the next video. So, with that said, see you guys in the next video. Bye!